All right, ready? Sure? Okay. Hi, everyone. Welcome to another episode of Mineral Live. Today, we're starting to get more suspension stuff, more modules out of the Cybertruck. So we've got the rear here on the table. I'm with Kevin. Today, we're going to walk through some of the things just at first blush that we're seeing getting this out of the vehicle. There's some things that are structural. There's some things from a thermal management perspective. And I think just overall packaging are some of the things that we saw initially speaking. So we'll start here. We want to connect it to the body in the conversation and talk about some of the structural decisions and trade-offs that they made, which we find quite interesting. So maybe I'll hand it off to Kevin. Kevin, why don't you give us kind of some highlights, some things that you saw when you first took a look at this?
So I think one of the first things that we, obviously because we were facing from the rear of the vehicle, was looking at the inverters. And essentially what looks like essentially swage marks for the cooling for the IGBTs of the inverter. That's what we kind of think. You can see essentially every exposed surface for the heat exchanger here is machined, which is interesting, obviously inexpensive. And then it looks like it essentially peened or swaged against the housing cover itself, which we thought was pretty interesting.
For those viewers, I know the acronyms, we keep getting torn up. So IGBT, this is a long one. It's insulated gate bipolar transistor. So that's essentially the electronics, the switching mechanism within the inverter, which is the thing that takes one type of electricity, converts it to the other, AC, DC, and gets power to the motors. So IGBT is insulated gate bipolar transistor.
Yes. And keeping them cool is critical for like EV performance in general. If you want to go fast and go fast for a long time, it's imperative to keep them cool.
Thanks to the Three-Dimensional Services Group for sponsoring this video. Whether you're looking to source metal stamping, precision CNC machining, laser cutting, welded assembly, or plastic injection molding, the Three-Dimensional Services Group should be the source to transform your EV, aerospace, appliance, or technology designs into reality, while also providing a bridge to start of production.
Hey boys and girls, I'm here with Dan, and we're at Three-Dimensional Services Group. And Dan, this is pretty impressive. Why don't you give us a little background on what you guys do here?
Okay, well, the Three-Dimensional Services Group was founded by Douglas Peterson 31 years ago. We've grown into the world's largest, most capable, and most agile prototype and low-volume manufacturer. In essence, we're a job shop on steroids. We work with the world's most innovative companies to validate their designs, and then we're able to take our low-volume manufacturing processes and scale them across a massive amount of equipment to allow us to support volumes that a traditional prototype shop would never be able to support. We're always working with our clients to accelerate their product development timelines and enable them to be as successful as possible by bringing their products to market as quickly as possible.
So, and then just as we were looking through here, as we started to migrate over here, Jordan was pointing out essentially something that they're doing, these threaded inserts. Anywhere where they do not have clearance, so ideally we wouldn't want to have to do this from a process step or cost step, but they simply don't have the clearance around some of these other components. So here they do, it's embossed and part of the casting. There they don't, and they add them. And you can kind of see systematically where they have clearance, they don't do it, and where they need clearance for manufacturing, they're paying the money for it. So that's one thing that was kind of interesting just here as we were looking at the back as well. One thing we were kind of talking to as well is the sway bar and the fact that it might be a little bit ad hoc, or they might need a little additional like locating retention for the sway bar itself. So you see these band clamps here locating this isolator around the sway bar, more than likely to help keep it from shifting left and right. Typically, we see pressed-on collars on the sway bar itself, whether they're on the outside on the bar or inside, co-located or overmolded with the isolator itself. So it's kind of interesting that we see it on the back and not integrated, but they may have tried to get away with not needing it and then decided to add if needed and go for the Spartan approach first. So
yeah, this is something though that like, and not to criticize Tesla, but something that I would say is not the most elegant execution in terms of the bushing. So, you know, contrary to what we're seeing in some of the other higher volume Teslas, there's some things on this vehicle that sort of give you the picture or allude to the fact that it is a lower volume vehicle. And accordingly, they're not able to leverage some of the same higher volume executions, right? So, for example, something like this, this is likely quite a manual operation to get these bushings on, and that's not great practice for a very high volume application. And by the way, just to give you kind of overall orientation, this is rearward in the vehicle. So this is the backside, the trailing end of the rear cradle assembly. So to kind of give everyone the orientation. So 2 motors, 2 plate cooling units on the top of the gearbox. So that looks like the thermal management strategy inside the motor and the gearbox units are very much so the same. So they've got jumpers going from their plate coolers to the inverters where they're running ethylene glycol, the coolant, you know, the water cooling, if you will, to and from those 2 different monuments. And then as far as the plate coolers are concerned, this is where from the inside of the gearbox, they are going to exchange 2 different fluid types, thermally speaking. They've got your gearbox oil and your ethylene glycol. So this is where they get to go back and forth in terms of the thermal picture. So when you want to heat the vehicle up, previous Teslas, what they would actually do is, in effect, it's more complex than this, but they would stall out the motors. That would create heat inside the unit. They would use the remote electric pumps to plumb oil into the plate cooler to heat up the ethylene glycol, to ultimately heat up the battery, right, which can mitigate the need for separate high voltage or what we'd say PTC heaters, for example. So it looks like they're continuing on with that strategy, but I would say overall, this whole motor and gearbox unit, I don't know how else to say it, is pretty massive.
yeah, it's extremely large. But one thing that's kind of interesting, if you remember on the Model S Plaid, there was essentially a huge girdle, and one of that ran cross car across the cradle and captivated the top of the unit. Well, there's a lot of packaging space here in the front on the front cradle shoehorns. The rear is not necessarily the case, right? They don't have that same packaging space there. So what's interesting to me, and I don't know, it's almost like a front cradle from the perspective of what lives on it, right? No, very, very few upper control arms live on the front cradle of a vehicle. So this has, its overall layout architecturally reminds me of a front cradle itself. Right. And you'll see here that there are no rear upper control arms. They're mounted and they're still on the body. So they are fastened to the body, and then the cradle is decked to and EDM assembly to the vehicle itself. So that's one thing I think is pretty interesting is, we have the lower control arm here, we have the tie rod, toe link, all that stuff going on. And then here's the upper ball joint that is getting located. And actually, Jordan, we think right here, essentially, there's like a clevis or a fixture that's probably going around here and like a quick pull pin to keep this all located. And maybe it even captivates like the ball joint in its position. So it decks from a trouble-free perspective. But that's what I thought was very interesting about this is essentially they're using the gigacasting that they bought and paid for to complement the structure of the cradle itself.
And I would say continuing with the upper control arm story, and maybe we'll walk over to the body for just a moment to talk about it, but I find it very interesting that Tesla has gone back and forth with respect to how they attach upper control arms. So as Kevin was mentioning, here's your upper control arm, the primary member that's controlling camber for that whole rear knuckle assembly, essentially the entire rear end of the rotor, caliper, knuckle, the half shaft, all that is connecting through this spot on the upper control arm. But they're leveraging all the structure in the rear gigacasting. So when I was saying they're going back and forth on upper control arm strategies, if you remember back to some of the early Model 3s and Model Ys, I believe, they had a cast aluminum piece that the control arms, the upper control arms on the front suspension mounted to, which allowed the front upper control arms on those suspension systems to be decked with the whole chassis unit, the whole chassis module as we would refer to it. Then, after the gigacasting came out for the 2022 Model Y, the new iteration, they actually changed their bill of process. So they got rid of that aluminum casting, and they took the upper control arms and they mounted them directly to the casting in the front. And that's essentially what they've done here as well. Different local execution, right? Different axes of bolt installation, you know, coming in the Z or top-down axis versus the X fore aft, right, where the bolts are coming through. But it is interesting to see Tesla, not just on different vehicles, but on front and rear in different suspension architectures, deploy different bill of processes as far as how they're executing.
And you know, one thing that should be noted, you know, the packaging space around here is extremely limited when we were looking at it. Yeah, before we de-decked, you know, the rear drive module, we were looking through this, and I mean, I think you can get to it from a service perspective, but you might be using essentially like an open crescent wrench to get it and get through and get these started to get them off if you had to swap them out later in life for serviceability. But it might just be easier to de-deck the entire cradle if you're replacing bushings to do everything all at once anyhow. But
yeah, absolutely. Yeah, and as far as rear control arms go, I mean, this is pretty hefty. It's carrying quite a bit. And right here, you've got your ride height sensors. So I do like the location of the ride height sensors. It really mitigates the necessity for super long linkages. Sometimes you see these ride height sensors. So as you go through jounce and rebound, right, these are like a potentiometer going to measure position of those and acceleration, how fast they're going up and down. So that's going to help with your air suspension positioning as well as roll pitch yaw of the vehicle, if you will, as you're going through dynamic scenarios. You know, going back to the cradle, Kevin, you know, we were talking a little bit about the rear steer unit. What are your thoughts on the rear steer unit? Like, we see Tesla's label there. It does seem like a compact unit. Any thoughts on the rear steer unit?
yeah, I mean, I don't know if they're building it in-house, but I would suspect it might be. If nothing else, it's most certainly probably completely internally designed in-house and maybe then sourced to a supplier, and then maybe with some very, very select components, you know, internal, like the motor and everything like that, and maybe the board for the steering rack, then being sourced, brought in-house, and then built up. But its overall packaging size, the way it's laid out it's definitely atypical and different than what we've seen in the past from, you know, suppliers like ZF or someone like that, you know, where we've seen these a lot on, you know, higher end Audis and Mercedes, but just the overall layout of this is very, very different. So
yeah, in some rear steer vehicles, this link right here that's attached to the steering rack or the unit, in some cases just acts like a tie rod. Like on a front suspension tie rod, it's going to help steer that knuckle. In this case, yes, it's doing that, but it's also acting as their toe link, right? So this whole monument is an active part of the suspension strategy. So there's a lower control arm, there's an upper control arm that attaches to this ball joint, which is pressed into the knuckle here with those arms going out to the body like we showed. And then this is their toe link controlling, obviously the four-wheel steering, but also, like I said, an active member of that suspension system. You know, kind of pivoting and going to the brakes, you know, just a couple of observations as we looked at it. It's a pretty large cast rotor, a lot of vehicle mass to control. We did notice they put some lightning holes in the rotor, so obviously pretty hefty vehicle. They're taking some mass out wherever they can. Not a bad strategy, you know, where grams matter in terms of how much mass they're trying to carry around. The other thing that we found sort of curious is this right here. So if you zoom in a little bit, Eric, right here, you'll see a little threaded hole, and that threaded hole is actually in the wheel hub, right? So there's a hole in the rotor, and there's another drilled and tapped hole in the wheel hub. Often those are used as assembly aids. So often the rotor will come assembled to this whole unit onto the hub, and the wheel's not yet installed, so there's no wheel lug bolts or lug nuts, depending on your orientation. Some folks do bolts, some folks do nuts, in this case nuts. But most of the time, if they're going to do this as an assembly aid, OEMs that is, this will be a permanent element of this system, meaning if you were to take the wheel off, I know we've got a Kia sitting just down the way. They actually have 2 of them, and they're still in place in production. What it appears Tesla's done is it looks like they use it for a period of time, but it actually looks like they're removing it prior to letting this vehicle ultimately roll off the assembly line. So kind of an interesting approach. If they are doing something as like a permanent fixture and getting some reuse, although it's just a bolt and you may not think that much of it, that is a cost-saving strategy that you could employ, right? It could be an assembly aid, but if you're using that bolt in multiple instances, you could save some cost.
Yeah, no, for sure. It's small, but they probably dropped it and lost it. But you know, when you walk a line and you see how many fasteners are just everywhere, sometimes unfortunately inside of vehicles, it's interesting. One thing I'm a little surprised at, and I get it from a packaging perspective, when you look at how much space here they have between the air strut and the CV axle itself, a fair amount of space there. Obviously, there's a lot of suspension kinematics dictating where some of this stuff goes, but you know, they kind of sandwich the control arm here. This rear one is essentially a stamped upper and lower. They use some lance and lock features here to help locate the upper and lower halves of the control arm before welding. I'm a little surprised they didn't try to get sway bar link bolted through on the control arm. I want to say the F-150s do this, where they run through the control arm themselves, and they don't necessarily need a separate bracket. But obviously, when you look at how tight the packaging is, and the fact that you do need section throughout here, it just, you know, this happens when you can't package around that. So that's one thing I kind of thought was interesting, just looking at how tight everything is here in comparison to the forward part of the lower control arm.
Well, and truly, when you talk about wheel envelopes, meaning in a dynamic sense, some people will call them the beehive or the honeycomb, or I've heard all sorts of names, but essentially, if you were to look at every possible permutation and position of the wheel through all of the rebound and jounce movements and also turning, that grows when you've got 4-wheel steer. So, you know, if you can imagine a tire and a wheel here, now that we've got 4-wheel steer, this can now encroach on this space over here. And so like Kevin's saying, they need a certain amount of structure, but that structure's got a finite amount of real estate in which it can reside. So with that 4-wheel steer, you're really starting to encroach here and limit where this control arm can package based on where that wheel envelope is. So that's why a lot of this it's a nice tall thick section, but it is pretty shrink wrapped in the fore-aft direction, likely to accommodate that wheel envelope going through its motion. So yeah, very interesting. Similarly, in terms of dynamic envelopes, and we saw this on Rivian, if you were to look at a Ford Raptor or a TRX or anything off-road really, you would see very long spans between the inboard pivot point of the control arms and the outboard point where it connects to the knuckle. And really, that's going to allow you a lot more travel in your suspension. So with this air suspension system, the vehicle does go up and down quite a bit, or has the capability to. With these air struts, it can raise and lower. By going further inboard with those, it's gonna reduce the amount of acute angles that need to be present for both the bushings as well as the half shafts. You know, these half shafts, they don't like to articulate too much. So if this was in full jounce or full rebound, right, these pivot. This one plunges and pivots on the inboard side from the half shaft. The further away from the driven point on the motor to the hub that you can get, the better off you are as far as angles and having anything severe as far as acuity is concerned in the system. So off-road vehicle, sort of, right? You're seeing some of those things play out as far as the cradle is concerned.
It's also interesting that, you know, from the get-go, they're going so far inboard. So if you were to look at, you know, the Raptor, the TRX, stuff like that, they're starting off production trucks with an overall width, you know, wheel mounting surface to wheel mounting surface that's kind of dictated based off plant and some stuff and things of that nature. And then they add, right? So the only way to get, you know, travel or height on an independent front suspension, or in this case rear, is to go out and longer. So then they add flares and they push the overall envelope out, where just like with the Rivian, we're seeing that envelope being pushed inboard from the get-go architecturally where they're laying out pickup points, knowing they want travel to be in a certain range. It's just interesting.
I totally agree. And I think a lot of that's enabled by two things, and both are tied together. So one is that we're going with EVs, and two is when we have offset gearboxes, which is meaning, you know, they're not coaxial, meaning the the gearbox, the final drive unit of this system, is in a different fore-aft or z-axis space than the motors themselves. So what that allows them to do as far as the cross-car span is the distance between output and output right here, essentially what I'm demonstrating with my hands, can get shrink wrapped quite a bit. Versus if you had the motors, this spherical portion right here, the cylindrical portion right here, if that were aligned with the half shafts, everything would get pushed out substantially. So I think there's an advantage, and you're pointing out, Kevin, like with Rivian, to going EV, going offset gearbox, and they can start much further inboard, just sort of from an architectural enabler perspective than some of the ICE counterparts, like the TRX and the Raptor, for example.
Right. Or even with the Lightning, right? Because that's concentric. So overall, the packaging width is notably wider.
Yeah, indeed. Yeah, I think overall it's an interesting execution from a structures perspective. I'm very interested to see how they executed the difference in, or kind of the lobbying, juxtaposition of the upper structure and attaching to the gigacasting, and really minimalizing the amount of structure needed for the lower cradle. Because if you were to look at that lower drive, or this rear drive unit, and then you were to separately on a table have that rear cradle, and you would be like, hey, does that cradle go to that drive unit? I probably would have guessed no, because you're not seeing the full picture, which still lives in the body.
Yeah, it's been interesting.
Yeah, indeed. Well, we're going to get further into it as the teardown progresses. We'll get the halves off the motors. We'll dive further into some of the electronics and the other tech. So thanks for joining us. Please stay tuned. And if you've got further questions, reach out at sales@leandesign.com. Thank you so much.
Thanks.